Welcome back to Factory Flow, your destination for industrial automation insights. Today, we're diving deep into industrial motor control systems, focusing on two key technologies: variable frequency drives, VFDs, and soft starters. We'll explore how they work, their applications, and how to choose the right one for your operations. Let's get started. In industrial applications, controlling motor speed and torque is crucial for efficiency and energy savings. Two common solutions for motor control are variable frequency drives, VFDs, and soft starters. While they both play an essential role in starting and controlling electric motors, their functionalities, applications, and benefits differ significantly. This detailed explanation explores how VFDs and soft starters work, their advantages, and how they compare in practical use. What is a soft starter? A soft starter is a device designed to limit the initial inrush current and gradually ramp up the voltage supplied to an electric motor during startup. It achieves this by using solid-state devices like thyristors to control the voltage. The gradual increase in voltage reduces mechanical stress on the motor and connected equipment, minimizing wear and tear. Soft starters are widely used in applications where a motor requires a smooth start but does not need speed variation during operation, such as pumps, fans, and conveyors. These devices are cost-effective, simple to install, and maintain. However, their functionality is limited to providing a soft start and stop. They cannot regulate motor speed once the motor reaches its rated operation. What is a VFD? A variable frequency drive, VFD, on the other hand, is a more advanced motor control device that not only provides a soft start, but also allows precise control of the motor's speed and torque. It operates by converting the incoming AC power to DC and then back to AC with adjustable frequency and voltage, using power electronics like inverters. This control over the frequency directly affects the motor's speed, making VFDs ideal for applications requiring variable speed operations. VFDs are commonly used in industries where process control is critical, such as in HVAC systems, conveyor systems, mixers, and pumps. They offer significant energy savings by reducing power consumption during low-demand periods. Additionally, VFDs provide advanced features like torque control, braking, and fault monitoring, making them highly versatile. Working principles. Soft starter. A soft starter uses thyristors to control the phase angle of the voltage, gradually increasing it to provide a smooth ramp-up to full voltage. This prevents the motor from drawing a high inrush current during startup, which can damage electrical components and increase operational costs. VFD. A VFD operates through rectification, inversion, and modulation. First, it converts the AC supply into DC using a rectifier. Then, an inverter converts this DC back into AC with a controlled frequency and voltage, allowing the user to regulate the motor's speed dynamically. VFD versus soft starter. Control capability. Soft starter. Limited to soft starting and stopping. No control over speed during operation. VFD. Full control over motor speed, torque, and acceleration-deceleration. Energy efficiency. Soft starter. Does not offer energy savings once the motor reaches full speed. VFD. Optimizes energy consumption by adjusting motor speed based on demand. Cost. Soft starter. More cost-effective for basic applications. VFD. Higher initial cost, but greater long-term savings due to energy efficiency and versatility. Applications. Soft starter. Suitable for simple applications like pumps and fans where speed control is unnecessary. VFD. Ideal for applications requiring precise speed control and variable operations. Let's look at the industry leaders providing reliable VFD and soft starter solutions. Siemens, Synamics, VFDs, Sirius, soft starters, known for robust designs and wide industrial applications. ABB, ACS VFD series, PSR PSS PST soft starters, offers energy-efficient solutions with advanced motor protection. Schneider Electric, Altivar VFDs, AltiStart soft starters, focuses on sustainable and digital energy solutions. Rockwell Automation, Allen Bradley, PowerFlex VFDs, SMC soft starters. Industry leader in automation and motor control. Danfoss, VLT drives, MCD soft starters. Specializes in HVAC, water, and in both. Soft starters and VFDs are essential tools in motor control, but their suitability depends on the specific application requirements. If your goal is to reduce mechanical stress and ensure smooth motor startup, a soft starter is an economical choice. However, if your application demands dynamic speed control, energy savings, and enhanced functionality, a VFD is the better option. Understanding these differences allows industries to choose the right device for improved efficiency, reduced operational costs, and extended equipment life.